Welcome to the Michael Shermer Show. I'm your host, Michael Shermer. My guest today is Steven Koonin. His new book is called Unsettled: What Climate Science Tells Us, What It Doesn't, and Why It Matters. I knew Steven when he was provost at Caltech, when we had our Caltech Science Lecture Series through the Skeptics. And I know of his work as a theoretical physicist and so on. This book, I was a little apprehensive about having him on because I've already had Bjorn Lomborg and Michael Schallenberg on, and I got some flack for that, even though they're not really climate deniers in the kind of traditional sense, and neither is Steven. So we get into that. We go through the big five questions, as I always phrase this whole subject. Is the Earth getting warmer? Is human activity the primary driver of the warming? How much warmer is it going to get? What are the effects of the warming and what we should do about it? So he agrees the Earth is definitely getting warmer, and human activity is really probably the primary driver of that, although he points out the natural cycles of heating and cooling and storms and droughts and so on. But still, nevertheless, there is some effect going on there. But what he focuses on in the book and in our conversation is the levels of uncertainty in the IPCC reports themselves and other government agencies, and he's been part of all that. I give him a proper introduction here for his bio. He's a leader in science policy in the United States. He served as the Undersecretary for Science in the U.S. Department of Energy under President Obama, not Trump, where he was lead author of the department's strategic plan in the inaugural Quadrennial Technology Review. With more than 200 peer-reviewed papers in the field of physics and astrophysics, scientific computation, energy, technology and policy, and climate science, Dr. Koonin was a professor of theoretical physics at Caltech, also serving as Caltech's vice president and provost for almost a decade. He is currently a university professor at New York University with appointments in the Stern School of Business, the Tandon School of Engineering, and the Department of Physics. And this bio goes on and on. In other words, he's the real deal. He's a world-class scientist. He's not a climate denier. And I think our conversation well addresses the levels of uncertainty. I did take the host prerogative to look up all the critical reviews of his book, and I read them, not sentence by sentence, but I read the central critical points of the book, and then he was familiar with all of them. He knows these other scientists that critique him. He has responses to their critiques, which he respects and acknowledges, but has a rebuttal, and I think that's the way science is supposed to work. So I will include those in the show notes that go along with the show. And to me, the most interesting part is, well, what do we do about all this? Because there are no, as Tom Sowell says, there are no solutions. There's just trade-offs. So what are the trade-offs if we do X, Y, or Z, depending on the problem, and what's the time horizon and so on? So I thought it was a very interesting and constructive conversation about getting our minds around the central points of the debate and the topic of climate science. So hope you appreciate this conversation. If you like the show, give us some support at skeptic.com/donate. That's our primary source of supporting the podcast through the Skeptic Society. We are a 501c3 nonprofit. So if you like the podcast and our work in combating pseudoscience and irrationality and promoting science and critical thinking, then do give us a little love there. Skeptic.com/donate. Thanks for listening and enjoy the conversation. Unsettled: What Climate Science Tells Us, What It Doesn't, and Why It Matters. Well, one thing that matters in this conversation is politics. Unfortunately, ever since climate science got bundled with Al Gore and the Democratic Party, it's become kind of politicized, such that I think people on the right, the moment they hear global warming or climate science, they think, oh, that's one of those libtard causes, and I have to be against that. So, unfortunately, we have to talk about what your own publisher put below your name, which is to say, former Undersecretary for Science, U.S. Department of Energy under the Obama administration. Because, of course, if it had said the Trump administration or Bush administration, people would go, oh, one of those. So give us a little bit of background. I remember you from Caltech, and you have a lifelong career as a theoretical physicist and so on. How did you get interested in this particular topic? Kind of give us a brief bio.
Yeah, so I was educated in New York City public schools, grew up in a middle-class household, went to Caltech as an undergrad because it was the late 60s, and California looked much more interesting than New York at that time. back at MIT for a PhD, and then back at Caltech, where I was on the faculty for 30 years and was the provost for the last 9 of those years. Trained in nuclear physics, applied quantum mechanics, did a lot of wonderful research. In the late 80s, I joined a group called JASON, which is a group of mostly academic scientists and engineers who work on the most important problems for the U.S. government, many of them classified. And in the late 80s and early 90s, I got exposed to climate science because the Department of Energy came to Jason and said, well, what about applying then new multiple processor computers to climate modeling and small satellites to climate observations? And I got intrigued with that and learned a bit about climate science, climate observations, climate modeling. Along in the late 90s, early 2000s, I started to get interested in energy through conversations with colleagues. And the opportunity came along in 2004, after I had been provosting for 9 years, to go be the chief scientist at BP. John Brown, who was the CEO, called me up and said, Steve, come help figure out what beyond petroleum really means. They didn't need me to find oil and gas. They were pretty good at that. And so I picked up the family in 2004 and moved to London, shifted from academia to the private sector. And for about a year and a half, I like to joke I was the world's highest paid graduate student as I learned energy. I know energy is conserved, but this is practical energy. And it was a wonderful experience. And I helped them quite a bit, I think, plot out their initial foray into renewables, particularly biofuels, but also wind and solar. After living in London for 5 years, my wife was getting kind of tired of that, as I was. And my friend Steve Chu, Nobel Prize-winning physicist now at Stanford, became the Secretary of Energy, and he said, come help out. And so I spent 2.5 for Obama. This was in early 2009, as the Obama administration was forming up. And I wound up doing pretty much what I did for BP in the Department of Energy, namely figuring out technology strategies. What technology should the government be investing in order to reduce emissions, to improve energy security? How should it go about the process from basic research to development to demonstration to deployment? Which technologies really mattered, could make a difference, and so on. And I did that for 2.5 years. The average time for a Senate-confirmed appointee is 18 months or so. So I stuck it out and felt I made a lasting impact. And then I left the administration and went to New York University to start a center about big data for big cities. That seemed like a very interesting thing to do at the time, and New York was a great place to do it. Did do that for 6 years. And early on in that period, about 2014, I was asked by the American Physical Society, the society that represents 50,000 physicists worldwide, to have a look at their climate statement, the statement that they had issued in 2007 about climate change. It was already 7 years old. It was time to refresh it. And the IPCC had just come out with their 5th assessment report at that time, so it was a ripe time to have a look at climate science again. I didn't want to just rubber stamp what the IPCC was saying, or the media, or the politicians. We were physicists, after all. We're capable of understanding these things. And we can form an independent opinion about the data, the quality of the modeling, the projections, and so on. And so, with a little bit of effort, I convened a workshop in Brooklyn in early 2014 with 3 consensus expert climate scientists and 3 people who were not fully on board with the consensus. And my committee from the APS, which was 5 or 6 physicists and a number of other people in attendance, and we sat and talked for a day about what did we know, what didn't we know, how good were the models, what might happen in the future, and so on. All of that was recorded on a transcript, which is available on the web, so people can read it. And I came away a little bit shaken, or unsettled, if you like, from that discussion, realizing that the science was not as solid as I had been led to believe. I hadn't really looked deeply at the science until that time. I was focused mostly on the technology. And one thing led to another, and I wound up writing an op-ed in the Wall Street Journal in the fall of 2014, outlining some of the really significant problems that we have in the models and in our ability to reliably project the future. In the subsequent years, I watched the gap between what the politicians and the media were saying and what the scientific literature and the assessment reports actually said. These days, you hear the word climate crisis, climate catastrophe, emergency, etc., and that's not at all what the science says. I like to quote or paraphrase a line from The Princess Bride. You keep invoking the science. I don't think the science says what you think it says. And I eventually got to the point where I decided to put it all down in a book. The op-eds and the talks would just not allow me to go into enough detail, present enough graphs, and so on. And so I wrote this book to try to give people a direct sense of what's in the official science, as opposed to getting it filtered through the assessment reports and then the summaries for policymakers and the media and the politicians and so on.
Give us a sense of what it's like to deal with a question like climate science from inside a place like a Caltech versus a place like BP, an NGO, and then inside a government agency. How do people think about problems like that differently in those different environments?
Yeah, so in the academic environment, it used to be, and I'm not sure it is now, you could discuss, debate, raise questions, and all of that was in the process of refining the science. That's how we do the science. In the private sector, it's much more goal-focused, and the goal ultimately is to make money. In my case, it was to try to skate to where the puck was thought to be, namely, how do we make BP into a company that is more respectful of the environment, particularly in climate. And so they weren't so much interested in the science that was taken as gospel from the IPCC. And in fact, it was what technologies can we develop, what businesses can we get into in order to try to make money, which is, after all, what the purpose of the private sector is, by providing services and goods that people want. And there weren't many other people who could push back on the science, even if I had raised the issue then. In terms of the government, the administration has a line. And there's a saying, if you're in the government, if you take the king's shilling, you've got to do the king's bidding, or something like that. And I could quietly discuss some of these things, but anything outside of the administration was verboten. You just couldn't do it. And, I got by dealing with the economic side of this, or the demographics in economics, simply by showing people the data and showing that there would be a massive energy growth in the next 40 to 50 years, and that fossil fuels were and remain the primary source of the world's energy. 80% come from fossil fuels these days, still. So those are the differences. These days in academia, I've got to say it's become a much more claustrophobic environment. As I've discovered in going public with the book, I actually knew it was going to happen. You immediately get dumped upon, in most instances, for non-scientific reasons. But some people raise good, legitimate objections to what I wrote, and I've been trying to respond to those as they arise.
Yeah, I have those teed up here. We can get to those specific points later, but use the term energy security. What does that mean from a government's perspective? Like, it's our job as the government to make sure that our people, citizens, have enough energy to lead a decent life?
Not only have enough energy, but that it is delivered reliably. So let me make a distinction between security and reliability. Security is about the physical provision of energy, fossil fuels, uranium, perhaps even some of the fancy hardware that goes into the electrical grid, which is manufactured abroad. And we saw a dramatic example of energy security in the Arab oil embargo in the 70s, when it was very difficult to get enough oil. Fortunately, up until recently, the U.S. has been producing more oil than it actually consumes. And so we become, in that sense, energy self-sufficient. Certainly true for natural gas these days, largely because of fracking. A real-world current instance of energy insecurity is what's going on in Europe, where they don't produce enough natural gas. They need natural gas for heating, for industry, and for electricity generation, and they're having to rely on imports, mostly and increasingly from Russia, and that's not a very comfortable place to be geopolitically. And so that's what we mean about energy security. Energy reliability is a different story, and that is mostly, is the fuel capable of being delivered continuously? The refining supply chain, but more importantly, is the electrical grid able to deliver 99.9 something percent of the time? And we have dramatic instances recently of when the electricity fails, all kinds of chaos that can happen. So that's a little bit about energy security and reliability.
I live in Santa Barbara area here now, but grew up in Southern California. And yes, because of all the fires, PG&E, Pacific Gas and Electric, was sued into oblivion because of their non-upgraded equipment that was causing these fires. And we're still having massive fires. And I mean, there are telephone poles outside of my house here that are being replaced slowly by Southern California Edison that are from like the 1940s. And, my wife's from Germany, and she's like, my God, you guys are so behind. And it's like, well, you got bombed into oblivion, so you got to start over fresh. We don't want to do that.
There's another aspect of the electrical utility business, in that these are regulated utilities, and they cannot freely tend to the problems that they see, but have to navigate carefully with the PUC, in the case of California, the Public Utility Commission. And if the Public Utility Commission says, you got to put in a lot of renewables and we're not going to give you money to trim those trees back, then you've got a problem, right? So a lot of the fire situation in California is a mix of forestry practices, which have allowed the forest to grow, development practices, which places towns like Paradise in the middle of a tinderbox, and changing climate, some of which is certainly anthropogenic.
Right. Smokey the Bear has done such a good job at preventing forest fires that now there's a lot of fuel to burn.
Absolutely. Fires in the West, if you go back to 1920, there were probably 5 times as many acres burned each year as there are currently.
Mm-hmm.
And that happened even as the globe warmed.
Right.
So it's a lot more complicated than just, a warming planet.
Yeah. I drive an electric car. I like to think that, someday there'll be no more fossil fuel driven cars. And that seems like a good thing to me, but I don't see how that can happen without nuclear energy. What is the current status of renewables, solar, wind, geoengineering, and geothermal, and so on, without nuclear versus with nuclear?
Yeah. So, right. So, a bigger picture on the grid for a minute, okay? We'd like the grid, the electrical grid, to have 3 things. We'd like it to be affordable, we would like it to be reliable, and we would like it to be low emissions. Okay? And there was an old statement in the Cold War, smart, honest, and communist, choose 2 out of 3. Right? So for the grid, it's affordable, it's reliable, and it's clean. Choose 2 out of 3. If you want a grid that is affordable and low emissions, wind and solar are the way to go. All right? The problem is, first of all, they're not very reliable. That the wind blows when it blows, if you want it to be affordable and reliable, then you've got gas, coal, nuclear. But if you want to make that clean, you need to get rid of the fossil fuels. You need to have wind and solar, but then you need some what's called firm or dispatchable power, ways in which you can fill in the shortfall when the wind and solar don't generate.
Batteries.
And it's fun. Batteries are certainly one possibility. Pumped hydro is another, where you pump water up a hill and then let it come down when you need the electricity. Converting electricity into some chemical, hydrogen, for example, by electrolyzing water, and then burning that chemical when you need the electricity again. So there are a number of ways, not only nuclear. But I would say right now the only way of squaring that or triangulating those three desiderata is nuclear power. And right now nuclear produces, I don't remember what the exact number is, 18-19% of the U.S. electricity. We know how to do it. The problem is it's too capital intensive and too expensive. When I was in the government, and the government has since continued to try to build much smaller nuclear reactors in a standardized way. Right now, our reactors are custom built and are typically 1.1 gigawatts of electricity. If we can build a 50 or 100 megawatt one, we can install them successively in a site. You build them in a factory, truck them there, or put them on rail, install them one after the other. The problem is to get the cost down, but first you got to get it licensed, and that's undergoing at the moment. So as you know, I'm a nuclear physicist by training, and I have a great love for fission, but we'll see whether we can get it cheap enough to do that. The thing that costs in a clean grid is not the generation. Wind and solar are the cheapest ways of generating electricity, but the grid is much more than generation. And the most expensive part is ensuring reliability, not ensuring the electricity.
Is the problem with nuclear in part psychological or social, in the sense that people fear it? They fear what they can't see, smell, taste, and touch, and then you throw in some availability heuristic of things like Chernobyl, and maybe a few movies like the China Syndrome, which came out the same week as 3 Mile Island. So people have conflated all this in their mind, and the major cause of deaths in Fukushima was not the nuclear power plant; it was the tidal waves, right, and the breaching of the wall and so on.
Right.
And so
one guy died of a heart attack trying to fix the plant. Yep. Yes.
Right. So the government then feels like, well, we got to regulate this. We can't have a Chernobyl on our turf. And then you end up getting a restriction of innovation because they're not allowed to have a period of failure, trial and error and failure, because the consequences are so high.
Yeah, I think it is largely a perception issue. I would add to your list of reasons people don't like it is the association with nuclear weapons, which are, of course, a terrible thing when they're used, but they're useful when they're not used in deterrence. And then there's the waste issue. All of that is technically soluble, but there is the perception issue. Way back, maybe 20 some odd years, or maybe more, 30 years, Spencer Weir, who's a great historian of science, wrote a book called Nuclear Fear. And he went through all the psychological reasons why people were not fans of nuclear power. But I think it's going to be absolutely essential if the world is going to get to zero emissions on the timescale it thinks it needs to do.
Yeah, so what about nuclear fusion? You remember cold fusion, and what a debacle that was.
Oh, do I remember?
Even Gary Taubes wrote a book about that, Bad Science. It was, one of the classic examples of that. And, every 5 years or so, you hear little rumors like, ooh, it's about to happen, it's going to happen. And this experiment, then it wasn't then they're not replicable, and then it fades away for a while.
Yeah. So, fusion has gotten closer with advances, which I'll discuss in a moment. But, if you believe we need to solve our energy problems in the next 30 years, given the time scale to develop, demonstrate, and then deploy, I don't think it's going to be a very big part of the near to midterm solution. Let me describe what the advances have been, and the world's mainline approach has been ITER. It's a big tokamak where you confine the plasma magnetically with magnetic fields. It's being constructed in the south of France. It involves, I think, 7 national partners: U.S., U.K., or EU, or maybe U.K. these days as well. I don't know. Russia, China, Japan. And it's 2 to 3 times over budget and a decade or more delayed. The first plasma happens in a few years, and the first introduction of fusible material sometime in the 2030s. And then we get to build a demonstration plant. All right. There have been 2 other developments that suggest maybe there are other ways of doing this. One is the rise of private sector magnetic efforts. A company I've been consulting with in full disclosure for about 16 or 17 years, except when I was in the government, is called Tri-Alpha. And they've got a significant hundreds of millions of dollars capitalization and have been making good progress on demonstrating a different kind of magnetic confinement, basically in a tube rather than in a donut. We'll see. They're, again, making good progress. They're going to build their next machine in the next few years. That will get closer to conditions where you could start to believe making energy. Another, so and then there's another, sorry, go ahead.
Oh, I was going to say.
This may be too much detail, but I don't know.
No. This is all really, this is gold. And we have no hard out, so we can get it detailed as you want. So, but I'm gathering from this that the idea of a world operating on complete renewables, which includes the whole basket of everything you just said, is probably not going to happen until the 22nd century, maybe.
I think that's a fair statement.
Yeah. So in the meantime, you have all these developing countries that want to come online and join the developed world, and they need energy. And at the moment, fossil fuels are still the way to go to get 2 or 3 of the three-legged stool. And it's hardly fair, it seems, for us and Europe, the UN, the EU, to say, no, you can't do that. Well, what are we supposed to do then? Well, can we go nuclear? No, you can't go nuclear. Okay, so it seems like we're kind of bumping up against a political issue there as well.
Right. Yeah. So and a moral issue, I would say. So to put some numbers on your statements, which are perfectly correct, and I agree with them, 40% of the world's people right now, that's 3 billion people, don't have adequate energy. And as they develop and improve their lives, they need energy to do that. And 80% of the world's energy right now is fossil fuels. It is the most convenient and reliable way of getting them energy. And people have used the term eco-colonialism or eco-imperialism for what you described as the developed world telling the undeveloped world, no, you need to use more expensive sources of energy. I summarized it in the book with the line that I actually have been asking people for 17 or 18 years. Who is going to pay the developing world not to emit? And I don't have an answer to that. And I haven't heard a good answer from anybody else either. So the dream of an emissions-free world by 2050 is completely ridiculous.
Right. That's not going to happen. And the protocols and agreements that we go in and out of, even if we met those, even if all the UN countries met them, it still wouldn't have the kind of effect we like to think it would by, say, 2200.
No.
And that seems to be a problem.
Another aspect of that is your risk calculus. How seriously do you rate the climate risk compared to all the other things you've got to worry about? It's very different for those of us in the developed world versus somebody sitting in Bangladesh or sub-Saharan Africa or even India. I think they would say, well, the climate risk is a couple of generations away and it's pretty vague. And my immediate needs are energy for a refrigerator or for lighting so I can study at night or whatever it is, or mobility. So let's get that first, and then we can worry about reducing emissions.
Yeah,
That's
one more
what they
point
would
on
say.
that, on the comparison of fossil fuels to nuclear. No one died at 3 Mile Island, or as some wag said, more people died in the backseat of Senator Kennedy's car at Chappaquiddick than died at 3 Mile Island. It's kind of a crude way to put it.
It's true. I mean, if you look at the statistics, nuclear is by far, the lowest in deaths per megawatt hour produced, by far, by orders of magnitude. I mean, with coal, you've got local pollution, gas, you've got the mining issues and so on. So the safest is by far, by experience, nuclear, even with Chernobyl, 3 Mile Island.
These 40% of the world that have energy insecurity, I guess you'd call it, where are they getting their energy from? Are they still burning, cow pies and wood and crude sources like that?
10, so 80% conventional fossil fuels, another 10% traditional biomass, as it's called. So yes, cow pies, or maybe a bit more politely dung, and wood. And that's used mainly for heating and cooking, and the local air pollution associated with that in the homes is just terrible. And if you've ever been to a city in the undeveloped or underdeveloped world, you smell the wood and dung burning just in the air walking around in the city. That kills millions of people a year through local air pollution. And so, even though propane or LPG might emit carbon, if you bring those fuels to such people, clean burning, then you've improved their health situation dramatically.
Right, but it's gradual enough, those deaths, that they don't make the news. Much like Hans Rosling used to point out that, every single day 137,000 people are lifted out of poverty, but it doesn't happen on a Tuesday afternoon with a film crew at 2:00, and here they are. They're no longer in poverty. It just happens over years and decades, and no one notices. And the opposite direction would be these fossil fuel deaths, related deaths. You just don't see it. But a 3 Mile Island or a Fukushima or a Chernobyl, that's, a massive story.
Of course. And people, some people would say it sounds heartless, every death matters. But in fact, what we're really talking about are the large trends and the statistics in trying to deal with the climate problem and provide adequate energy at the same time.
So let's talk about the core of your book here, that, what we know and what we don't know. I break it down into 5 different questions. 1, is the Earth getting warmer? 2, is human activity the primary driver of the warming? 3, how much warmer is it going to get, and on what time scale? 4, what are the effects of this warming going to be, depending on that time scale? And 5, what should we do about it? So okay. I trust from what I read your book, so I know you agree, yes, the Earth is definitely getting warmer, and humans have some role. From there, I take it you diverge from some of your colleagues. We actually held a conference at Caltech, the Skeptics did, and I had Tapio Schneider, your colleague, kind of give us the overview.
I helped hire him. He's a fine scientist.
Oh, nice, right.
Okay. And,
but at this point, I suspect you and he might diverge a little bit from the, how much warmer is it going to get, and to what role do non-human activities play a role, and so on. So let's start there.
So let's talk about how much warmer. So let's back up a minute. The climate changes for a number of reasons, not just CO2. There are other greenhouse gases, methane, nitrous oxide being the most important ones. They're not as problematic as CO2. Of course, water vapor is the biggest greenhouse gas, but none of that, very little of that is human caused. And then there are the aerosols, the particulates that are put up when we burn dirty fuels, and also natural aerosols. And these exert a cooling influence. And it's about 1/3 of what the greenhouse gases do, so the net is 2/3. And you've got to, if you say, what is it going to do in the future, you've got to make some assumptions about what the future looks like for all those emissions. And then you've got the model uncertainties. Even for a given amount of greenhouse gases and aerosols, the models respond in very different ways. Some warm by only 1 degree when you double carbon dioxide, 1.5, and others warm by 5 or 6 degrees. And so you've got to fold that model uncertainty together with the uncertainty about future emissions and also natural variability. The climate does vary on its own, and you've got to somehow take that into account. So it's a difficult problem scientifically. We do know some things. Okay. So the most recent UN report said that the sensitivity of the climate has got a range, and that range is a little bit less at the high end, so it's not quite as sensitive. It may not be quite as sensitive as we thought, but also a little bit more raised on the low end. It used to be 1.5 to 4.5 degrees if you doubled CO2, and the latest estimates now are 2.5 to 4. And so the community is narrowing down the sensitivity, although I think there are still credible people who would say it's outside that range. So you've got the model sensitivity. Yeah, sorry, go ahead. Please.
I'm not sure I know what climate sensitivity means. You mean how variable it could be depending on what factors?
No. If I held all factors the same except raised the CO2 to twice its pre-industrial value, so went from 280 parts per million to 560, and let it all come to equilibrium, which takes some time, centuries, by how much would the temperature, the average surface temperature, go up? So it's a measure of how sensitive the model is.
I see.
And as I said, there's still a fair bit of uncertainty about that.
Right.
So it's 2 to 3 degrees, or maybe 4. Your next question is, of course, what's it going to do? What are emissions going to do over the next century, say? And of course, we don't know. It's a complicated combination of demographics, of development, of what technologies we deploy, regulation, economics. And so the IPCC, or the community generally, doesn't try to predict, but writes down a set of scenarios that have so much development, so much population, so much emissions of all these components. Changes in land use are important as well. And it used to say, up until the most recent report, we can't decide among the future whether it's going to be a very low emission scenario or a very high emission scenario. We're just going to calculate them all to give a sense of the range. And the human influences in those scenarios by 2100 differ by a factor of about 3.5 or 4. So there's one at 2.5, 2.4, and another one at 8.5, and that grades how much CO2 basically there is, or forcing there is, to the climate. In the recent report that came out on August 9th, so a couple months ago, they broke with that tradition and said the 2 highest emission scenarios are unlikely. And that has been actually in the literature now for quite a while, which is a little bit ironic because, there had been a promotion of those high emission scenarios as business as usual. And of course, when you feed them into the climate models, particularly the more sensitive climate models, they can predict dramatically bad stuff. All right. So they now backed off. And if you take what they believe to be a reasonable or plausible scenario, it's got a number 4.5 instead of the 8.5. You get a temperature rise to 2100 of another 1.5 degrees on top of the 1 degree that we've already seen since 1900, 1.1 degrees since 1900. So the warming relative to pre-industrial, to 1900, or even a bit further back, will be about 2.5, 2.7 degrees, which is a lot less than the dire predictions that we have seen in previous reports, or at least the dire scenarios. So what the impacts are going to be, well, we can talk about that after I take a drink of water.
Yeah, please.
Right.
Let me just comment a little bit.
Is that enough, by the way, on
yeah,
those topics?
that's perfect.
Happy to
yeah,
go
that's
more.
perfect. I'm going to comment about, you mentioned, we don't know for sure. Well, of course, we don't know anything for sure. We're not Laplace's demon or the omniscient deity.
Yep.
So everything is operating under uncertainty, but we have, in a Bayesian way, kind of degrees of credence in a hypothesis based on the evidence and so on, which changes. So this idea of like a climate consensus, and you mentioned the 97% versus 3%. So here's what I wrote in Scientific American I wrote one of my columns on this. A 2013 study published in Environmental Research Letters by John Cook, Dana Nuccitelli, and their colleagues examined 11,944 climate paper abstracts published from 1991 to 2011. Of those papers that stated a position on anthropogenic global warming, 97.1% concluded that climate change is real and human-caused. What about the 3%? What if they're right? In a 2015 paper published in the Journal of Theoretical and Applied Climatology, Rasmus Benestad, Dana Nuccitelli, and their colleagues examined the 3% and found, quote, a number of methodological flaws and a pattern of common mistakes. That is, instead of the 3% converging to a better explanation than that provided by the 97%, they failed to converge to anything. Quote, there is no cohesive, consistent alternative theory to human-caused global warming, they concluded in a commentary in The Guardian. Some blame global warming on the sun, others on orbital cycles of other planets, others on ocean cycles, and so on. There's a 97% expert consensus on a cohesive theory that's overwhelmingly supported by the scientific evidence, but the 2 to 3% of papers that reject that consensus are all over the map, even contradicting each other. The one thing they seem to have in common is methodological flaws like cherry picking, curve fitting, ignoring inconvenient data, and disregarding known physics. For example, one skeptical paper attributed climate change to lunar or solar cycles, but to make these models work for the 4,000-year period that the authors considered, they had to throw out 6,000 years of earlier data. Anyway, your comments.
First of all, there is no such thing as a consensus in science, as you know. What really matters are the data and your ability to explain it and to make what Popper called risky predictions. Okay, that's the gold standard, the coin of the realm in science. As far as the 97% study, I think you will find, and people have thoroughly examined the methodology and have concluded that it was pretty flawed. And in fact, people have spoken up whose papers were counted in the 97% consensus and said, I don't believe that at all. And then there's the issue of, well, what exactly are we saying people believe in? Do I believe that the globe is warming? Absolutely. Do I believe that CO2 is going up because of human activity? Absolutely. Do I believe that that's exerting a warming influence on the globe? Absolutely. Do I believe that that's going to be catastrophic? Well, no, because I read the reports. Everything I've written in the book is right out of the consensus. And so, to call me a denier or a skeptic, no, I support the consensus. It's just that the science doesn't say what everybody thinks it says.
Yeah, that word consensus, it's a little misleading in science, although maybe there's a better word, just, convergence of evidence, a consilience of inductions, William Ewell called it in the 19th century. For example,
that's good.
For example, the Big Bang theory has a consensus that's probably more likely than the steady state theory, and that was resolved in the 1960s. And by the 70s, it was pretty clear what the correct answer is. Now, it doesn't mean steady state theory is 100% wrong and the Big Bang's 100% right, but it's pretty probable, high probability. And so when someone like me, an outsider, I'm not a climate scientist, I'm not a physicist, I'm a social scientist, so. Because I publish this magazine, Skeptic, people send me these, you must have gotten these at Caltech, these theories of everything. Einstein was wrong, Newton was wrong, Stephen Hawking was wrong, and I've worked it all out in my basement, and if you help me with the math, I'll share the Nobel Prize with you. Right. So people like you are probably too busy to respond, but I would often write them just to see what their thinking is. And but I don't really need to study physics to know whether I can just ask someone like Kip Thorne, hey, what's the story with this on quantum physics thing or something, cosmology? And he'll go, no, here's the flaw. Yep. Oh, okay. Now, I'm not arguing from an argument of authority, like Kip Thorne is my guru and I know he's always right, so I'm going to ask him. I just trust that people like you have challenged Kip, and you guys have had debates, and you publish it in journals, and you go to conferences, and you argue amongst each other, such that by the time it trickles down to me, I can be reasonably confident that when you guys say the Big Bang probably happened, the universe is expanding at an accelerating rate, and here's how we know because of these type 2 supernovas and blah, blah, blah. And I can go, okay, I accept that. Why do I accept it? Well, it's not faith. It's not argument from authority. It's that I have confidence the system works pretty well. So when someone like you writes a book that says, well, I'm skeptical about parts of climate science, and then I run into the 97%, they go, no, we're very confident in that. I can't tell if you've uncovered some inconsistencies there that the 97% missed, or if I'm not even configuring that the correct way.
Right. So people have, most of the criticism I've gotten has been, guilt by association and ad hominem attacks. But there have been some substantive scientific criticisms. I don't know if you've seen the responses. I've been responding to them. I believe I've effectively countered most of them. They attribute things to me that I never said, or they bash me for not providing detail, which actually is in the book. Many of the critics have not read the book. All right? So, this gets to the tenor of the debate. Let me give you an example. So Kerry Emanuel is a prominent climate scientist at MIT. He's one of the world's experts on hurricanes. And he was one of the fact checkers that weighed in on some number of points I made in the book. And I asked Kerry afterward, I can tell you what he wrote and what he criticized, which I think most of it is nonsense. I said, Kerry, did you even read the book? And he said, no. So this is the tenor of the debate among senior academics on this stuff. It's just, it's very disheartening. All right. Let me tell you what Kerry said, which is kind of amusing. So he writes, you can find it. These things are up on my Medium website, and you can find my response. Kerry says in his, he puts on his Cambridge professor voice, and you can just imagine the bow tie, and says, anyone who has any familiarity with the record of hurricanes would not talk about trends over a century. It's only the last 40 years we got data. And okay, I'm no hurricane expert, but I can read the papers, and I read the assessment reports. And right there in the IPCC fifth assessment report and the more recent one, it says there are no trends over centennial timescales. And my dictionary says centennial, all right, is century. So Kerry, I think, was being a bit prissy, shall we say. I will have a chance to chat with him in about a week at MIT, and we'll see how that discussion goes. What I take most beef with is not the science itself, but the way in which it's presented to the public with absolute certainty. Let me give you one example, another example. When the most recent IPCC report came out on August 9th, the Secretary General of the UN, Gutierrez, issued a statement that said, this report is code red for humanity. Unless we stop emissions promptly, we're going to put billions of people at immediate risk. Well, I doubt that he's actually read the report. You can find the word climate crisis or the phrase climate crisis in the report. So the report does contain that word, but it contains it in the context of describing how the US and EU media misrepresent the subtle nature of the science. It's got nothing to do with the scientific substance of the report itself. So, it's stuff like that from the US administration, from the UN, from the EU, from the IPCC itself that really gives a distorted picture of the certainties, uncertainties, risks that we face from a changing climate. And that's what annoys me.
So, just to put a point on that, you're saying that let's use another scientific term, the error bars are too wide the further out you go, such that we really can't say with high degree of certainty what's going to happen in 2100 because there's too many factors and the sensitivity of the models is not high enough to make a prediction like that?
That's part of it. As you get to regional predictions, which are what are important for people's response, the experts even say that the models are almost worthless. But nevertheless, they're promulgated out. I can give you references where people publish this in peer-reviewed journals. But nevertheless, people somehow take this as gospel. The other aspect is not only the error bars are large, but in some cases, the reports themselves say the impact will be minimal. And I go through that in the case of agriculture and crop production, and also, to me, most surprisingly, aggregate economic activity. The reports say that the impact of a warming of even 6 degrees by 2100, remember Paris is all about 1.5 or 2 degrees, will be a few percent, 5% of the either US or global GDP impact. And so, you might not believe that, and I don't, but it's right there in the report. And I should probably give that as much credence as people give to the climate models. So if it's only a few percent, why are we talking about a climate crisis?
Well, in part, that's what sells books and makes good TV shows and films and news stories. But I think
more than that, it's what frightens voters. It's what frightens voters.
Yeah,
H.L. Mencken said in
let's leave out
let's talk about that.
Okay. That's right. H.L. Mencken, yes, that's right. You have a great quote from him.
Yeah, right.
Let's leave out the Greta Thunbergs of the world that, the world's not going to come to an end in 12 years and all that. Let's just leave that out and just kind of just admit that there's a lot of uncertainties. Probably not an existential threat like nuclear weapons still are to a certain degree.
I would love, if the scientific institutions, the national academies, the IPCC stood up and said, the world is not going to come to end in 12 years. This is perhaps a serious problem. It's not existential. That would be scientific integrity. And you don't see anybody doing that.
Yeah. Well, and it might make people feel like they can actually do something about it. I mean, when you present an apocalyptic scenario like that, it makes the average person like me figure, well, what can I do? Nothing. And then you have a game theory problem where no one of us can make any difference at all. All of us have to do something simultaneously, but who's going to be first? And,
exactly.
And again, back to the developing countries are saying, well, you go first because we want to get to be a developed country and so on. Okay, just some specific things like climate scientist Gary Yohe, professor of economics, environmental science at Wesleyan, reviewed your book. He quotes you, quote, heat waves in the U.S. are now no more common than they were in 1900. And that the warmest temperature in the United States has not risen in the past 50 years, close quote from you. And he says this is a questionable statement depending on the definition of heat wave, and so it is really uninformative. Heat waves are a poor indicator of heat stress. Whether they're or not they're becoming more frequent, they have clearly become hotter and longer over the past few decades, while populations have grown more vulnerable in large measure because they are, on average, older. Final sentence then. Moreover, during these longer extreme heat events, it is nighttime temperatures that are increasing most. As a result, people never get relief from insufferable heat, and more of them are at risk of dying. Your response to that?
So there are lots of layers to what he wrote. Let me first say that I'm surprised that Professor Yo doesn't know the official assessment reports, because the statements about heat waves and warmer temperatures are directly shown in 2 or 3 key figures in the 2017 Climate Science Special Report, CSSR, issued by the U.S. government. I can point you exactly to those references where that's shown. Most people are surprised by that. exactly what the definition of a heat wave is and warmest temperature. It's all explained in the report, not mine. This is not my science. This is the allegedly official science of the US government. Now, what the impacts are and so on, I don't talk about that. That was not my point to be made. The point I was making when I wrote all that in the book was that these are surprising things that are there that people don't know. And moreover, that particular report has a gross misrepresentation of how the record temperatures are changing in the US. My chapter 5 spends some pages on that. Again, this is an official US government report, allegedly the best advice that the government can give to decision makers, and it's got these errors and misrepresentations in it. And I think that really means that we need a much more rigorous review of these reports as they're prepared.
He writes, quoting you, the warmest temperatures in the U.S. have not risen in the past 50 years, close quote from you. He writes, according to what measure? Highest annual global averages? Absolutely not. But the planet is as warmed as it has warmed since the Industrial Revolution is unequivocal, with more than 30% of that warming having occurred in the last 25 years, and the hottest annual temperatures in that history have followed suit. You do usually see at the end of every year saying, well, this was the hottest year ever, and last year was the record, and the year before that was 8 of the last 10 years of the hottest ever recorded, and so on. That looks like it's getting warmer.
Well, he's responding to not the point I made, okay? The point I made was about warmest temperatures in the U.S. over the last century. The definition of that is clearly explained in the U.S. government report. Again, it's chapter 6 of the Climate Science Special Report. Anybody can look those figures up and see them. And I'm surprised that Professor Yo didn't do that, say Koonin is right, but there are these other factors. That would have been an acceptable response from Professor Yo. By the way, a third party was trying to arrange an in-person debate between me and Professor Yo in the next few months. He declined.
Really?
Yes.
Wonder why.
I don't know. I never had any communication with him.
He addresses Greenland's ice sheet isn't shrinking any more rapidly today than it was 80 years ago, your claim from the book. He says, he writes, for a risk-based approach to climate discussions about what we should do, this statement is irrelevant. It is the future that worries us. Observations from 11 satellite missions monitoring the Arctic and Antarctic show that the ice sheets are losing mass 6 times faster than they were in the 1990s. Is this the beginning of a new trend? Perhaps. The settled state of the science for those who have adopted a risk management approach is that this is a high-risk probability, high consequences, that should be taken seriously and examined more completely. This is even more important because even without those contributions to the historical trend that is accelerating, rising sea levels will continue to exaggerate coastal exposure by dramatically shrinking the return times of all variety of storms.
Well, again, Professor Yo doesn't address the point. First of all, my claim that Greenland was contributing to sea level rise melting as rapidly 80 years ago as today is not my claim. It's right there in the published peer-reviewed literature, and he doesn't deny that, if I could use that verb. The fact that it was doing that and then went down and is now going up again suggests that there's a lot of natural variability in the system, since human influences were much smaller 80 years ago than they are today. And unless you take that natural variability into account to allow you to isolate the response to human influences, your projections of the future are likely to be way off, one way or the other. So I raise it not to dismiss the recent rise, but just to say it may not be what you think it is. And until you understand the historical record, which is relevant to the future, you're not going to be able to do a reasonable projection of the future. That's all. Right? By the way, do you know that sea level shows the same thing? It was going up rapidly in the 1920s, 1930s and 40s. Then it went down, and then it went up again. So, and even today, the rate is all of 1 foot per century. All right? 1 foot per century. I think we can manage that. When you look at the IPCC projections, even for the next decade, of local sea level, let's say here in New York, which is, of course, I looked that up, it's so far out of what we have experienced that we're going to know pretty soon whether they're right or not. And my bet is that it's going to be a lot more moderate than anybody thinks it's going to be. Again, I've got graphs in the book that go through that discussion.
So what you're arguing is that we have to have a base rate by which to compare any current changes. Daniel Kahneman calls this the base rate neglect, which is a huge problem in estimating any kind of thing you're trying to measure. He used in a different context of medical diagnoses. You got to know what the base rate is.
Yes.
And so but as I understand it, it's like a millimeter a year. So over the course of a century, I guess that's
it's 3 millimeters a year globally, but the local rates are different. So 3 millimeters a year is a foot a century. Let me tell you a story about denial, all right? And I don't mean climate denial, I mean the river Nile, okay? And this is relevant, as you'll see, so bear with me for a minute, okay?
All right.
The river Nile was, of course, very important to the ancient Egyptians. And so they were measuring it. And in particular, they measured the height of the maximum every year, which was the flooding, was very important for agriculture, and the height of the minimum. And we have data of those annual values starting from about 640 AD and going for 900 years. These were taken at Rhode Island in Cairo, where they built a special structure to measure in cubits the height of the Nile. And when you look at that data, I have a graph of it in the book, but not this particular interpretation. It was measured in cubits. Did I say that? Not meters, but we know how to convert. You start in about 650 AD, and you look at the year-to-year fluctuations, and they are enormous. 1 year it's 5 meters, and the next year it's down to 1 meter. So it fluctuates a lot. It's largely due to the level of water in Lake Victoria, which feeds the Nile, drains about 10% of the African continent, about a third the area of the US. So this is a good regional climate measure. But if you take a running average, a smooth trend, what you see is it starts in about 670 or so at about 3 meters, and then it takes about almost 100 years to go down to 1 meter. And you can just imagine some medieval Egyptian IPCC saying, new normal. We've got to pray and do some sacrifices and so on. And sure enough, you wait another century and it goes back up higher than what it was. So there are enormous, at least at the regional level, enormous long-term fluctuations in the climate that can mask anything having to do with human influences. That's in part why I take the predictions or the attributions with more than a grain of salt.
But as I understand it, it's the accelerating rate of change that's different from historical trends that go up and down. That since the Industrial Revolution, the speed at which the Earth has gotten warmer, say compared to 100 million years ago or some paleo data sets, where it does go up and down quite a bit. And you can say, well, the Earth was warmer 600 million years ago or whatever. Their point is that, but it's kind of slowly versus the hockey stick. Yeah. And
the most recent temperature rise we're concerned with from 1970 is 50 years, right? When you look at these paleo methods, there are essentially none of them that have a resolution of 50 years. If you're lucky, you got 50 years as 1 point in the time series. And so we really don't know about the rapidity of warming and how unusual it is.
Here you're talking about these ice core drills that they make, and they pull these long columns out. That's one. And they drill in and suck out a little bit of the air from 100 million years ago or whatever, and they can see the parts per million. So on,
Yep. Yep,
Okay.
absolutely. Many other things as well from the ice cores. A wonderful chronology of stuff that went on in either
Yeah.
Greenland or the Antarctic.
Yeah. Yeah. It's amazing. But this idea that the sea levels rise about a foot per century, but your entire data set is only a century. So how do we know
Yep.
how much it's going to go up and down?
Well, we don't, okay? And, geologically, we know, let's say, over the last 20,000 years since the glaciers started melting, the last maximum of the glaciers, that it's gone up 120 meters. Okay, 120 meters, 400 feet. Okay, and now, yes, it took 100 centuries or 200 centuries for that to happen. But nevertheless, that's a tremendous rise. The rises we're talking about today are millimeters per year. 2 millimeters a year. So,
But
we'll
but the
see.
causal
Okay,
mechanism.
as I said, the IPCC predictions are so dramatic that we'll know within a decade whether something bad is going to happen.
So the graphics you see in films like Inconvenient Truth, where Manhattan is swamped in water, even the IPCC wouldn't go along with that?
No, not for many centuries, certainly. Okay, it is true that the last time the Earth was in an interglacial, namely, it was not fully covered or partially covered with ice, that the ice sheets were small, was 124,000 years ago. It's called the Eemian. We believe the temperature was about 2 degrees warmer, and sea level was 6 to 9 meters higher. Okay, 20 some odd feet higher than it is now. That's, of course, an entirely natural process. So we have seen high sea levels before. It changes a lot. Whether what we're seeing is natural or anthropogenic or some combination yet to be determined, I think is up for grabs.
Yeah, it's good to remember that. Just parenthetically, there was that discovery made last week of fossilized footprints in New Mexico, dated at 23,000 years ago. Well, what were people doing here 23,000 years ago when we thought it was more like 13 to 16,000 years ago?
Yeah.
And how'd they get here? Because it was all under ice. Well, my theory, just the theory that I like, is that they came down the coast in boats. Well, where's the archaeological evidence for that? It's 300 feet underwater because of the sea level difference.
Well, okay.
And so it's gone.
We should go look. All right.
Well, there is a field of underwater archaeology. Okay, there was something about on Greenland that you were talking about, glaciers inside, deep inside Greenland that did not trickle down to the sea versus the glaciers on the margins that are melting.
I don't think I said it. I don't think I. No. Yeah, I didn't say anything about that.
No. Okay, I'm misreading never mind. Yeah. Okay. Let's continue here. What was I going to ask you on this? Here's some 5 points that I found. This is from a climate journalist, Marianne Lavelle, Inside Climate News. Probably seeing this one. Here are 5 statements Koonin makes in Unsettled that mainstream climate scientists say are misleading, incorrect, or undercut by current research. 1, the warmest temperature. Okay, we went through that already. Warmest temperature. So she writes, the average annual temperature in the contiguous U.S. has increased from 0.7 degrees to 1 degree Celsius, 1.2 to 1.8 Fahrenheit, since the start of the 20th century. The year 2020 was the 5th warmest year in the 126th year of the contiguous U.S. recordings, and the 5 warmest years on record have occurred since 2012, right. NOAA reports.
Right. So, all true. Okay, I wouldn't dispute that. Those are about averages. And, I think I acknowledged that in the book. The discussion of temperatures in the book is about record-breaking temperatures.
It is explain the theory behind the idea of more extreme weather events because of increased warming. Is it that if you put more energy into a system, the winds go faster, there's more rain, the droughts are worse, the snowstorms are worse?
Yeah, that's, at some level, that's a pretty good discussion. Even though, so you look at the expert predictions for hurricanes. And while we've seen no trend in hurricane properties, we can get into that a little bit if you want in a while. The predictions for how the hurricanes are going to change show only a 10 or 20% increase in some of the metrics for 2-degree warming. So this is by no means a catastrophic thing at all, even according to their predictions. Similarly, the predictions of agricultural impacts. I remind you that crop yields have gone up spectacularly since 1960. The world produces more than enough food to feed itself now.
But that's for other reasons, because we're better at farming.
Well, actually, the CO2
the Green Revolution
has helped. Yeah, but also the CO2 has helped, and the longer growing seasons have helped. The predictions in IPCC, projections, show a minuscule change in food prices by the middle of the century. Lots of uncertainty, of course, but small compared to the market fluctuations that we see every day. So again, it's a nothing burger as far as agricultural impacts go. Right?
Here's the thing
on Greenland. Again, this is not Steve saying that. That's not Steve saying it.
I understand.
It is what's in the reports.
Right. Right. So
Greenland,
Yeah, Greenland. So scientific findings indicate with a high confidence that the Greenland ice sheet, the world's second largest land-based ice reservoir, has lost ice, contributing to sea level rise over the last 2 decades. And Greenland is on track to lose more ice this century than at any other time in the last 12,000-year Holocene. Let's see, scientists reported in 2020. That's in Nature. The rate of ice melt in Greenland has varied widely over the decades, which you point out. And there is evidence of a period of rapid melting in the 1930s that you talk about that exceeded the rate of today. But, she writes, the 1930s era melt affected fewer glaciers, mostly those located entirely on land. Today's melting involves more glaciers, most of them connected to the sea, with average ice loss more than double that of the earlier period.
Well, my statement still remains true. If we can start to understand what caused the earlier melting, then we can say with confidence that it's not operating today. But that's not true. So again, you need to explain past natural variability if you're going to attribute with confidence. And I don't think we have that.
Yeah, well, that's kind of the central point of your book, is not so much that it's denying anything. It's just saying we don't know with the degree of certainty that you hear about in pop culture media and so forth. Every hurricane, tornado, heat wave in the news is now attributed to climate change, and you simply can't always say that. It takes a little bit of rigorous science to determine that.
Let me give you another recent example. We had a great downpour a couple months ago here in New York City from the remnants of Hurricane Ida. And, they said it's the rainiest 1 hour, a couple of inches of rain fell in Central Park in 1 hour, which was a record. So I tried to look up the historical record of rainfall in Central Park, and I couldn't find a long record of 1 hour rates. But I could find a long record of 1 day rates going back to about 1860 or so. All right. And it turns out that recent day was only the 5th rainiest day on record. It was 7.5 inches, and the rainiest day on record was about 8-point-something inches and happened in 1879. All right. So 140 years ago. All right. And there are 4 other days that are rainier, and they're spread out over the time between 1879 and the current. All right? So people forget weather. And if you're going to do climate, you need to remember weather over centuries, or at least a century. And the media play that up, as you noted. Every hurricane, every tornado, every weird event. And there are many of them around the world. There's always weird events around the world. The question is, are they becoming more common? Right.
You probably know Nadir Javanji, science advisor for Sea Change Conversations, right? So he praises your book. He likes parts of it. And then I just pulled out the one, but, because of course that's always coming in a review. But our confidence in these climate changes doesn't stem solely from the observational record. In large part, it stems from our understanding of basic physics and climate model projections, which show that increased CO2 leads inexorably to a warmer planet, and a warmer planet leads inexorably to melting ice, higher seas, and more extreme weather. Unsettled, your book, ignores such projections entirely, arguing that because climate models require empirical adjustments known as tuning, and because their quantitative predictions often span a wide range, they cannot be trusted to tell us anything at all. But these models, despite their shortcomings, are skillful in many respects. Indeed, they have long predicted many aspects of today's warmer climate, including enhanced warming over sea and the Arctic. So when these models tell us unanimously that heat waves will increase, sea level rise will accelerate, and hurricanes will intensify, we tend to believe them even if we can't prove yet, he says parenthetically, that the changes we're currently seeing are definitely due to climate change.
Yeah. So Nadir's a great friend. Well, he's an acquaintance. He's a good scientist. I know him. You've got the climate modelers themselves saying that, at least for regional projections, the models are not fit for purpose. And the confidence in them, in these projections, the confidence that non-experts have is often very overstated. There's a paper, but in a peer-reviewed journal, you've got people saying, just don't believe the regional projections. Similarly, you've got another paper, again peer-reviewed by Tim Palmer and Graham Stevens, saying, while they give us some hazy picture of what's going on globally, they're not at all fit for purpose to do regional projections. So, again, I'd like to have a conversation with Nadir about those points. And we should remember the models are adjusted, all right? So to say, I reproduce the past, many of them actually don't reproduce the past with enough fidelity. To say I reproduce the past is no guarantee. Past performance is no guarantee of future performance, or whatever the stock guys say, right? It's a worthy enterprise. The IPCC devotes so many chapters to it in the last report, 40% to model projections. But as I say in the book, I sure wish they were better than they are.
Mm-hmm. And then the final, criticism here, I think I'm on board with you on this, is that global warming, climate change is leading to inequalities between nations or peoples or races or whatever criteria people are making comparisons of. And I'm not sure at all that climate washes over all the other economic and political factors that go into inequalities. How do you think about the kind of human consequences of climate change?
Yeah, so let me turn to the economic impacts. I've mentioned that a bit already. The last IPCC report, or the most recent one that weighed in on this issue, which was already some years ago, 6 or 7 years ago, said that climate change is only one factor that weighs in on economic well-being, and it is other factors, demographics, development, technology, regulation, so on, are relatively larger and more important. And in fact, when you look at what they said quantitatively, significant warming what you take away is a few degrees of warming is a few percent impact at the end of the century. And if the economy is growing at 2%, as people expect for both the US and the world, then 4% impact is 2 years of growth. In other words, instead of the US economy quadrupling 70 years from now, going from the present 20 million to 80 million, it would be instead something like 76 billion instead of 80 billion. And 70 years from now, you can't project with that kind of confidence. So it's in the noise. Now, whether you believe that or not, we can have a discussion, but that's what's in the report.
Yeah, I think the analogy you used is that whatever wealth we will have accumulated in 2100 it will be delayed by 2 years because of climate change, which would be not even noticeable, really.
Right. So let me make the following point, which is, I think, another important one. The globe warmed by 1.1 degrees from 1900 to now. During that time, despite hiccups, world wars, so on, during that time the population quadrupled, and we saw the greatest advance in human well-being in recorded history. Health, longevity, education, nutrition, you can go on and on. Do we really think that another 1.5 degrees of warming over the next century is going to significantly derail that?
No, I don't.
No. All right. Good. Good. So the next time President Biden or Ambassador Kerry or Secretary Gutierrez or even people like Bill Gates start talking about a climate emergency and climate catastrophe, let's ask that question. Why do you think it's going to be a catastrophe or crisis or emergency?
Yeah, very few people give an actual causal sequence of events that would give the mechanism of how you would get from here to there, that is to catastrophe. But let's say they're at least partially right, or let's err on the side of leaning more toward the worst case scenario. Thomas Sowell famously said there are no solutions, they're just trade-offs. So even if we start ramping up the restrictions of fossil fuel use and consumption and whatnot, do the whole thing, what does that cost? And how is that going to affect the economy in 2100?
So, I won't give a precise number for how it's going to affect the economy, but a couple of general principles are useful. One is that William Nordhaus won the Nobel Prize in Economics in 2018 for the following realization: that if you try to decarbonize the economy too rapidly, you will incur increasing costs. Energy is so interwoven into everyday life and into the economy that making big changes in it, we can get to the Biden plans in a while if you want, but making big changes in it is going to be disruptive unless you do it with some deliberation. On the other hand, if you decarbonize too slowly, you load up the atmosphere with more CO2, and the climate risk goes up. And so there's an optimal pace of decarbonization, which lets the temperature rise to some value at, let's say, 2100, and then starts to bring it down. If you do it too fast, you're disruptive, and you also deploy mature technologies, so that incurs a cost. So when you look at what Nordhaus wrote in his Nobel lecture, he would say that the economic optimum is to let the temperature go up to 3 degrees by 2100, or even 3.5. Of course, there are lots of uncertainty. The politicians are trying to rein things in at 1.5 or 2 degrees. And so, to say it politely, they've gotten ahead of their skis and are pushing to do too much too fast. And if they push too much too fast, there's going to be popular pushback because energy will become more expensive, it will become unreliable, consumer choice will be reduced, energy insecurity will be increased. And we're seeing that already. Biden's trying to cut back on fossil fuels at the same time as he's begging OPEC to ramp up production of oil. So if you're going to decarbonize, it needs to be done thoughtfully and taking into account all of the relevant elements. Not only the energy supply itself, but the economics, the technology, people's perceptions of what's going on. We talked about nuclear perceptions before. Nobody has written down a comprehensive plan like that. And I would think that that's the first thing anybody would want to see if they said, let's decarbonize.
Right. Yes. What are the consequences of that? Since you wrote about this a little bit, tell us about your opinion of some of these engineering solutions, like we're going to spew particles through commercial airliners to have little particulate matter in the upper atmosphere that'll block the sunlight. What could go wrong there?
Oh, nothing, of course. It'd be, So my attitude about that is that if it were feasible, it would be a last ditch solution. And I'm in no way advocating for the deployment of that, which would, of course, require a great international consensus to do that. It's getting hard already to get a consensus to reduce emissions. But I am advocating for a better understanding of whether we have that tool in our pocket to use as might be required. And I'm not alone in that. David Keith at Harvard, I would say, mainstream climate scientist, has been pursuing a vigorous research program in that for the last few years, funded by Bill Gates, among other people. So I think it's an interesting hedge. We can get into what you need to know to have more or less confidence in whether it's a good thing or not. But I think, if you believe that the world is headed for a climate catastrophe, then you had better support that, because we need to know whether there is a life preserver or not.
And let me just finally ask you about economics. I know this is not your field, but you certainly have dealt with a lot of economists and policymakers. We just spent, $2 trillion on the Afghan and Iraqi wars. Trump himself, every conservative Republican president, they grow the government just as much as the Dems do. We just printed $1 trillion in COVID relief and sent checks out to everybody. Seems like a great thing to do. How nice. And now the Green New Deal, maybe we don't even go that far. What is that, $2 trillion? Maybe we only spend $1 trillion on the environment. At some point, isn't the other shoe going to fall? We're going to have massive inflation, or something's going to happen. And what are your thoughts on that?
Yeah, I'm not an economist, as you point out, particularly about those matters. But I do know that whatever spending we do should be, and maybe this is, idealistic and pie in the sky, should be a thoughtful consideration of the priorities that we have and the efficacy with which particular solutions will or will not work. And the US is only 13% of global emissions. And if we went to zero tomorrow, it would be wiped out by less than a decade's worth of growth of emissions in the rest of the world. And so even if the current plans to decarbonize come to pass, you're going to get all this turmoil that we talked about. People are going to start to ask, tell me again why we're doing this? We have many more immediate needs that are far more certain and far more short-term than worrying about some change in climate several generations hence and half a world away. And so again, I think time to take a thoughtful, prudent approach to the climate issues, develop the technologies, better understand what might happen in the future. Again, remembering Mr. Nordhaus, who said, you've got time. I think that's much more sensible, and let's spend the money on, obviously, public health, education, U.S. competitiveness, et cetera, et cetera. Okay? We're going to face, I think, serious challenges from China, both geopolitically and economically, and I would be focused on that and not distracted by trying to reduce our emissions.
And that would be a response to the precautionary principle that however much uncertainty there is, we should do something just in case. And the problem is which thing are we worried about? Well, climate gets all the attention, but what about China and whatever else?
Yeah. And is the thing you're going to do really going to have an impact on the something you're worried about? Right.
And what is that? It's often, loss of lives, but someone like Bjorn Lomborg presents that, if it's warmer, fewer people die because there'll be fewer people dying of cold than more people die of cold than of heat. And, you can kind of crunch those numbers, and it's not clear what the metric is. If you want to save lives, as he points out, just spend the money on mosquito nets for malaria or something like that.
Right.
Much cheaper.
Right. And if you really wanted to reduce global emissions, the U.S. should be spending its money helping China reduce its emissions, rather than squeezing out of the U.S. economy, right? Or California should spend its money in Ohio, where all the coal plants are, rather than in California, where you're pretty emissions light.
I know what I wanted to ask you. So this is a crazy question, but a couple of weeks ago, Bill Maher had a little riff in his new rules at the end of his show about the problem of drought in the West Coast and the problem of too much rain on the East Coast. Why can't we just build a pipeline from one end of the country and just ship the water to the West? And of course, everybody laughs like that's ridiculous. And then he points out, well, we do that with oil. We have these massive, long, thousands of miles long pipelines. Why can't we do that with water?
The problem is that the amount of oil that we ship, and I can't do the calculation in my head, but it's probably 1/10,000th or so of the amount of water we'd have to ship to make a difference. Okay? If you want to solve the California problem, you cut back on the water for agriculture. Right? 90% of California's water goes to agriculture, growing almonds and cotton, which are completely ridiculous in a water-starved environment. But that isn't going to happen because of regulations and, rights to water that were acquired decades ago and so on. So Mr. Marr is no friend of mine. As soon as the book was released, or even before it was released, he went off on a 5-minute tirade against this idiot Koonin.
I didn't hear that.
And I didn't watch it. My family watched it, and they just said that's absurd. So I think Mr. Marr should appreciate that a lot of the climate discussion is like religion, and he doesn't like religion. So you would think he'd understand that. But maybe someday I'll get a chance to go on the show and we can talk about this.
Yeah, I suspect that's not going to happen.
Nah.
Well, I was, speaking of religion, I was at the Caltech talk that Michael Crichton gave, I think the early 90s, I think it was, in Beckman Auditorium.
Yeah.
And
right.
And then when I held my conference with Tapio Schneider, I invited Michael Crichton to come and give his, climate science as a religion speech. And he did. He showed up. And, he's quite the intimidating figure. He was like 6'6", and this is about a year before he died.
He's a big guy.
He's a big guy, and he came in a limo with security, and it was really quite the happening. But he kind of begged off a little bit. I mean, he was not as extreme as he was. I think he might have been intimidated with having Tapio Schneider there, who really knows the science. I don't know.
Right. So it'd be great, and I may get a chance. I will next week, as I said, be at MIT, and we'll have a chance to talk with people who criticize me. Maybe I can get to do that at Caltech as well.
That would be great.
I will be next week at Purdue and talking to people there in public. So, I think I might be a little bit different than Crichton because I know
what you're talking about.
Science. I know where the skeletons are. Yeah, right. I know.
I'm not 100% I'm not 100% on board with your skepticism, but I do get a sense in reading your book and talking to you that you're a man of integrity. You do care what's actually true, and you're willing to assign probabilities in a Bayesian reasoning way of how do we know this is true? And you strike me as somebody who would adjust your priors up or down based on new evidence that came in. So I wish there was more openness to talking to people like you. I don't feel like you're out of the Overton window. You should be part of the conversation. I mean, you are, but more so, I think, because it's not clear that this is, to me, it's not at all clear this is an existential threat. But it feels like it seems to me it's something we should pay attention to. Maybe do something about it in the long run. Yeah. I'm optimistic, I think you are, and that humans are highly adaptable. Matt really points out we didn't leave the Stone Age because we ran out of stones. We are a creative, inventive species, and I think we can work our way out of this, whatever happens. I think we have the time. That was Nordhaus's conclusion, right? We have the time.
Yeah, of course, and we do have the time. What I would say, if you want a summary statement, the greatest threat is in precipitate climate action rather than in climate change. And let us take the time to think it through and do it in an optimal way.
That's perfectly put. Steven Koonin, thank you for your book and your work. And what's next on besides debating people on this, what's next on your research and or writing agenda?
Yeah, so, many people have said I should write an energy book, but I think the world has got a number of those already. I'm more interested in trying to educate people about the systems that make modern society work. Not only energy, but water, refuse, finance. These are mysteries to most ordinary people. I mean, I didn't really know about energy until I got into BP and started studying it. And when you understand it, it's a very different picture than what you get by, people just saying, well, let's put up a lot of wind turbines. And I see that in the classes I teach. I teach climate science in the fall and energy in the spring, and to graduate students. And it's great to see their eyes open up when you show them the data about energy technologies or climate and so on. So I'm thinking about maybe trying to do a book about society systems at the, again, popular level, so that I can help.
You have a nice blurb
my goal
from
in all of this is to,
you have a nice blurb from Vaclav Smil, who I never heard of until Bill Gates kind of put him on the map.
Oh,
I read a few of his books. He's
Right.
pretty technical, he's not a pop writer, but he seems to know his stuff. But stuff I've never thought about, like energy consumption.
Right. And I've been reading him for 16, 17 years, and he's one of my favorite authors on these subjects. My goal in all of this, like I think Smil's, is not to persuade people of one thing or another, but just inform them, and then let them fold in values, risk tolerance, etc., into what kind of decisions they would like to support. Right? I'm an educator at heart, and I just want to inform people.
Well, thanks for coming on the show to inform my listeners, and thanks for your patience while I ground through all the critics of your book. No author likes to read that, but that's how science works, right? So you have conjecture and refutation, as Karl Popper put it. All right, so we have a conversation. That's how we figure it out.
Right. So as a scientist for 40 years, and also as a provost for 9 years, I'm used to being criticized. So
that's right.
No problem.
Especially at a place like Caltech. Oh,
Very
boy.
good. Yeah. Right.
All right.
Absolutely. All right. Great.